Okay, let's do some subtraction. Now, you haven't actually learned this before, but I want to see if you can actually work out how to do it yourself. This one should be relatively easy. This one, think of the reverse way of doing binary addition. Pause the video, give it yourself a go first. I'm then going to do a solution. Okay, 1 take away 1 gives us 0. 0 take away 0 gives us 0. 1 take away 1 gives us 0. 1 take away 0 gives us 1. 1 take away 0 gives us 1. 1 take away 1 gives us 0. Nice and simple, that one. It's simple because there's no carrying involved. On the other side, we can't do 0 take away 1. This does not work. So we go to the next door neighbor and say, yo, you're going to become a 0 now. We're going to borrow your 1s. And we put 2 1s here. So in essence, we're going to be doing some subtraction. We're going to first of all subtract this one and this one, which will give us 0. But then we've also got this extra 1 left over. So 1 take away 0 gives us 1. We then move over to this column. Again, we cannot do 0 take away 1, so we go to our neighbor to borrow 1. But this column has no 1 either. So we go to this column. We say, we're borrowing your 1. We then put a 1 here and a 1 here like before. This column is like, I still need a 1 here. So it borrows a 1 from here. And we put 2 1s here. So whenever we borrow the column next door, we put 2 1s. That's the rule. So again, we're now going to do 1, take away 1, which gives us 0. And then this one, 1, take away 0, gives us 1. So we're left with 1 here. In this column, 1 take away 0 is 1. In this column, oh no, I cannot take away 0 take away 1. So we're going to go to this column to borrow 1, but there's nothing there. To this column to borrow 1, there's nothing there. To this column. So we're going to borrow that 1. But we need to borrow then this one. But this still needs a 1, so we're going to borrow again. 1 take away 1 is 0. 1 take away 0 is 1. On this side of things, 1 take away 1 is 0. 1 take away 0 is 1. 0 take away 0 is 0. 1 take away 1 is 0. And there we go. So let's do another example. Pause the video, give it a go yourself first. Okay. So 1 take away 0 is 1. 0 take away 1 we cannot do. So we go to this column here. We can't do anything with that one. So we go to this column here and we borrow this 1. We then stack this with 2 1s. But we still need to borrow here, so we cancel that out. And 2 1s here. 1 take away 1 is 0. 1 take away 0 is 1. 1 take away 0 is 1. 0. So let's double check this. So this is our answer here. If we were to turn this into denary, this will give us 2. If we were to turn this into denary, this will give us 9. 9 take away 2 gives us 7. This, therefore, should add up to 7. 1, 2, 4, 4 plus 2 plus 1 does give us 7. So that works. And you can do the same for these. We turn them into denary numbers. And then turn this into a denary number. It should equate. And same with this one. Turn them into denary numbers. And we should match Okay, so this time I would like us to do a 1 binary shift or logical shift to the right. Pause the video, give it a go yourself first. Okay, this is really easy. So we've got our 1, our 2, our 4, our 8. Simply going to go into this direction. 0, then 1, 1, 0. So we originally had 12, we now have 6. So doing a logical shift to the right is simply dividing it by 2 each time. Okay, let's do on the same number, another binary shift, but this time 2 places to the right. Pause the video, give it a go yourself first. Alright, so we've got 8, our 4, our 2, our 1, and we're going 2 spaces. So I'm going to start with this one. This is going to end up here. I'm just going to fill these up with zeros. This one is going to end up here, and we lose these 2. So what impact do we have by doing a binary shift 2 places to the right in this scenario? Well, we ran out of bits again. Running out of bits means that the accuracy of the number isn't low accuracy or inaccurate. It's probably better to say it's inaccurate because we've run out of bits. So this in itself is called an underflow error because we've run out of bits to represent the number by shifting to the right. When we shifted to the left originally in the last question we did, we had an overflow error because we didn't have enough bits to store the number accurately. So overflow is when we shifted to the left and we don't have enough bits there. Underflow is when we shift to the right because we've lost the 1 and the 0 here. It's not being stored anywhere. Therefore, we've lost the accuracy. So overflow, underflow errors.